Hello, and in this section we're going to continue our study of nomenclature, and this is just a little reminder that we want to make sure that we understand we're talking about the same compounds and we're not miscommunicating. So we're going to learn now about polyatomic compounds. What is a polyatomic compound? Polyatomic compound contains polyatomic ions. What are those? Well, polyatomic ions are ions composed of multiple atoms bonded together. Here is a chart showing some common polyatomic ions. These are actually all ions that you will need to be able to know and recognize. It might look a little bit overwhelming, but there are a few patterns in here that you'll be able to spot as you work with these polyatomic ions. But in order to name compounds, you're going to have to be very familiar with these and be able to recognize the polyatomic ions within the compounds. An oxyanion is a polyatomic ion that contains different numbers of oxygen atoms. And I just wanted to point this out to you because as you look on the chart here, you're going to start to notice some patterns. You can see that out of, let's start with nitrite and nitrate. You can see that for nitrite, it has two oxygens. When it adds another oxygen, we have nitrate. So we go from nitrite to nitrate. Sulfite and sulfate do the same thing. It isn't going from 2 to 3, but it's going from 3 to 4. So their common polyatomic ions will be the ITE ending will be the lower number, and the ATE ending will be the higher number. It's same for chlorite and chlorate. It goes from 2 to 3, and you'll have to just memorize which ones are 2 and 3 and which ones are 3 and 4. Two more interesting prefixes and that go along with that would be if we remove another oxygen and have one fewer oxygen than the ITE molecule, we end up with hypochlorite, chlor in this case. So if we add another oxygen to the ATE molecule, we end up with perchlorate. We have 4 instead of 3. So those are just some patterns that you'll notice as you start working with these polyatomic ions. So now let's name the polyatomic compounds. The rules for naming, you've seen a lot of these ideas before already, but we name the cation first, the anion second. Let's take, for example, this molecule. Now, the reason you need to become familiar with the polyatomic ions is that it would be very difficult for you to recognize that this happens to be the cation and this happens to be the anion. But we simply name it. This is ammonium. You can see that from right here. We have ammonium, and C2H3O2 is acetate from the chart right there. And we just call it ammonium acetate. If a metal is present that forms more than one cation, we use a Roman numeral to specify the cation charge, just like in the type 2 binary ionic compounds. So we're going to use that process again. Remember that first we want to determine the charge of the cation. So let's use this as an example. Here's iron, and here is nitrate right there. The ions present are iron plus 3 and 3 nitrates. The nitrates are -1 each, and there are 3 of them, so that we know that iron has to have a charge of +3 so that we get a net charge for the compound of 0. So we write this iron 3 nitrate. So why don't you try a few, see if you can get these correct, and see on the next slide if you get them right. Here are the answers. Here we have potassium for the cation, and the anion is hydrogen sulfate, and that's right here on your chart. For this compound, we have manganese, which is a transition element. So we are going to need to explain and put the Roman numeral in there to identify what kind of charge it has. Right here we have the hydroxide ion, and there are two of them. So manganese is going to have, hydroxide is -1 each, so manganese will have to be a +2 charge. So this is the name, manganese 2 hydroxide. I'm curious, just a review. If this is helpful for you, great. If not, that's fine. You don't have to use it. But right here we have sort of a little flow chart that was in the previous video, and it helps us remember when to use type 3, type 2, and type 1 processes when we are looking at binary compounds. So here, today, we just added this section. If we say that we do not have a binary compound, we're going to ask this question: is it a polyatomic ion, or are there ions present? Well, if it's yes, we're going to name the compound similar to procedures for binary ionic compounds, and we just learned how to do that today. If the answer is no, then it's a compound that we have not discussed how to name. So this is just a little reminder and a little review of how to name different compounds. So here are some helpful ideas for learning names and charges of polyatomic ions. It's a lot to learn. So if you made some flashcards for some of those common polyatomic ions that were listed in that chart, you'd be able to rearrange them and notice patterns and help yourself memorize some of those charges and names. Grouping the oxyanions together is helpful. Advanced proficiency. You could learn additional polyatomic ions. You could look up some of the common names that refer to those common polyatomic ions. Those are always a little bit interesting, and I'm looking forward to seeing you in class.